Hi everyone, welcome back to Civil Engineering with Amir. This is Amir here with another question from Craig's Mechanics of Materials on the topic of Hooke's law for isotropic material. Before we jump into the question, I want to ask you guys to hit the subscribe button on the right corner and subscribe to the channel if you haven't already. Okay, let's read the question together. Okay, so here we have an element that is restrained between two rigid surfaces. So this is our top surface and this is our lower surface, and this is our element. So it can be compressed in this direction, but in this direction its dimension cannot change and will remain the same. And now in this question, a compressive stress with a magnitude of sigma 0 is applied to this element. Now in part A of the question, we have to determine the value of sigma y. In part B, we have to determine delta A, or change in the x direction. So this is x direction, this is y direction, and this is z direction. Delta A will be in this direction. And in part C, we have to determine delta T, or the change of thickness of this element, which is in z direction. From the generalized Hooke's law equations, we know epsilon y is equal to 1 over E sigma y minus Poisson sigma x plus sigma z plus alpha delta t. And we know delta t is equal to 0 in this question, sigma z is equal to 0, and we know epsilon y is also equal to 0 because the dimension in the y direction cannot change because the element is restrained between two rigid surfaces, and rigid surfaces won't allow for this element to expand in this y direction. So epsilon y is equal to 0. And we know this sigma x is negative sigma 0 because sigma x is a compressive stress. So this negative sign shows that the element is in compression in the x direction. So we have 0 is 1 over E sigma y plus Poisson sigma 0. And this will give us a sigma y equal to negative Poisson sigma 0. And this will be the answer for part A of the question. And in part B, we have to determine delta A, which is the change in dimension in the x direction. And if we use the generalized Hooke's law equation in the x direction, we can say epsilon x is equal to 1 over E. And we know this epsilon x is actually delta A over A. Alpha delta t is equal to 0. Sigma z is equal to 0. Sigma y is negative Poisson sigma 0. This sigma x is negative sigma 0. And now we have so delta A will be equal to and since this Poisson's ratio is always between 0 and 1, this Poisson in the power of 2 minus 1 is always smaller than 0. So this will be a negative value, and the dimension in the x direction will reduce if we apply a compressive stress. Okay, now in the last part we have to determine delta t, or the change in the thickness of the element which is in the z direction. So epsilon z is equal to 1 over E sigma z minus Poisson sigma y plus sigma x plus alpha delta t. Sigma z is equal to 0. Sigma y is negative Poisson sigma 0. This is negative sigma 0. Alpha delta t is equal to 0. So delta t over t will be 1 over E. So delta t will be equal to Poisson t over E sigma 0 1 plus Poisson. And since 1 plus Poisson's ratio is positive, Poisson's ratio is positive, t is positive, sigma 0 is positive, and E is positive, this delta t will be positive, and we have an expansion in the z direction. Okay, that's it. Thanks for watching this video. If you found it informative and helpful, please press the like button. If you have any comments, suggestions, feedback, or even if you have any questions, please feel free to share your thoughts in the comment section. And finally, if you haven't subscribed to the channel yet, please hit this subscribe button in the right corner and support us. Thanks again for joining me today, and see you in the next video.